Hello everyone, I want to welcome you all to Data Science 101 class. It's going to be all about a predictive model on Harris plant using machine learning. Alright, so let's get started. The content we're going to be looking at involves the background study of iris, data visualization, preprocessing, transformation, and the predictive modeling. Alright, so from our study of iris, it's a flowering plant and then it belongs to kingdom Plantae, class Trichophyte, angiosperm, and the genus is iris. Alright, so the type of iris that we're going to be considering here is the iris virginica, iris setosa, and iris veriscol. So what we're going to do is we want to have a predictive model using machine learning to actually identify iris virginica from iris setosa from iris veriscol based on 4 key features, which is the sepal length, sepal width, petal length, and petal width. So we have 50 instances of the three classes. That makes a total of 150. And what I want you guys to understand here in this data is iris setosa is going to be class 0, veriscol will be class 1, and virginica will be class 2. Alright, so as we move on, we are going to be taking note of some statistics in the data just for us to have an idea of the data, and then we're going to be using this algorithm, machine learning algorithm called logistic regression to predict the class, the probability that if a feature or if a set of input feature actually represents setosa or virginica or veriscol. Alright, so let's get started. So here is the data here. So I have the data loaded from scikit-learn. The dataset has some scikit-learn has some datasets that we can use, and iris is part of it. So I'll be using pandas and numpy for my preprocessing and transformation. So we have the features, and then I converted it into a data frame. Now you can go ahead and then check out some statistics and visualization of the data, and to do that you do the describe, and then you have the separ, the count, the mean, the standard deviation, the minimum value, the lower percentile, the median, the upper percentile, and the maximum value for each of the feature. So you can go ahead to do some visualization. Here I'll be using Plotly. Plotly is an interactive web-based data visualization library in Python. Alright, so I'll be going ahead to use that. So I have a visualization. I'm visualizing the sepal against the petal. So here is so here is the sepal width, the relationship, and here is the sepal length, the relationship. There's some sort of linear relationship in the sepal length, but not really so much relationship with the petal width. So all these things basically gives us an insight into what our data is all about. So we can go ahead and do some more visuals. You can see some, linear relationship between the features one another. You can do some you can check out the distribution of the data. Now let's move ahead. So but before we go ahead, I would love to talk about something before we do some modeling, and that's the box plot. Box plot basically helps us to find outliers in our data. So when we did a box plot of all our data, the sepal length, the petal length, sepal width, and petal width, the sepal width has some sort of outliers. So in order to remove that, we can have some little math here, and then once we check it again, you discover that everything is all gone. We don't have outliers again, so we can go ahead to build our model. So we'll be using the train test split method from the model selection class from the scikit-learn package. So we are going to be specifying test size to be 0.2, that is 20% of our data will be used for modeling, and then stratify will be equals to y, such that we can have equal distribution of our data from between the train and the test data. So we'll be using logistic regression that I spoke about earlier. So on using logistic regression, after training we had 97.5% accuracy, and then when we tested the model we had 96.7% accuracy. That shows that our model actually learned a lot. So here's the classification reports, the precision, the recall, the F1 score of each of the class being demonstrated, and here the confusion matrix. We only have just one misclassification of the data here. Alright, so I want to believe that you've been able to comprehend everything I've been able to say thus far. So I want to believe you understand. Thank you for watching.